Is there gravity in space? And there's a really, really simple answer. Yes, there is gravity in space. And particularly in orbit, it's actually quite similar to the gravity on the surface of the Earth. So why do we hear the terms microgravity? Why do we see astronauts floating freely in the space ISS? Why do we hear the words weightless? Now, do you like fun fairs? Do you know the rides that just plunge straight down? Now, for perhaps a second or so, you actually don't feel that you're attached to your seat. You feel almost weightless, even though you're in the Earth's gravitational field. Therefore, this helps us to understand how we can feel weightless while still actually having a weight. And the reason is what we experience is not really our weight. What we experience is the reaction force. And we're going to use this to explain as why we can be weightless, but yet there is gravity in space. And we can understand this because if we consider space-time, if we consider space without any mass, without any gravitational fields of being flat, there is no field acting, there is no force due to gravity. But as soon as you put a large mass there, we have a sphere of influence. Now, we show the sphere of influence in 2 dimensions. The reality, it's in 3 dimensions, and you could argue it might be in more, certainly in 4. Now, put a mass there. When we say a mass, we mean planet-sized or moon-sized at least. It distorts the space-time around it. It literally means if I have another mass in that area, for instance, it is literally going to create a field where that mass experiences a force to it. And the closer I get to the center of that mass, the stronger the force gets. It's by something known as the inverse square rule. So, we like to use the analogy, it creates a gravity well which will pull you in and require a significant amount of kinetic energy to get back out again. Let's think about the moon's gravitational field. So here we have Artemis 1, our Orion spacecraft, orbiting around the moon. It feels something. It's in a gravitational field. The moon creates that gravitational field. The spacecraft has a mass, so it experiences a force. Why does it not fall then towards the moon? What stops it crashing? Because it has a velocity, an orbital velocity, a component which is tangential to the actual moon, to the radial direction to the moon. It doesn't actually have to be tangential. It has to be tangential for circular orbits, but not all orbits are circular. So this means that it kind of falls, but as it's moving tangentially, it falls at the same rate as the moon sort of falls away. It's a little bit of an analogy. So it does something like this. So the spacecraft feels a force to the center of the moon's mass. We know that it does because if there was no force, according to Newton's first law, if there was no force acting on that, or resultant force, it would simply carry on in a straight line.